Bismillahirrahmanirrahim. Hello everyone, I hope you are all doing well. I welcome you all in class of Real Analysis by Robert G. Bartle. In today's lecture, we will discuss how to solve absolute value equations and inequalities. We will discuss question number 6 to question number 10 in this single lecture. So let us start from question number 6. Question number 6 says we have to solve this inequality for every real number x. The inequality is absolute of 4x minus 5 less than or equal to 13. I will use here a fact which says x absolute is less than or equal to some positive real number a if and only if we can write minus a less than or equal to x, x less than or equal to plus a. So by using this fact, we can write this inequality as minus 13 less than or equal to 4x minus 5 less than or equal to plus 13. Now we solve this inequality for value of x. Adding 5 on both sides, we have minus 13 plus 5 less than or equal to 4x. This is less than or equal to 13 plus 5. This is equal to minus 8 less than or equal to 4x. This is equal to 13 plus 5 is 18. Next, dividing 4 on both sides, this gives 4x over 4 minus 8 by 4, 18 by 4. This is equal to minus 2 less than or equal to x, x less than or equal to 9 over 2. So the solution set of this inequality is all those real number that lies in the interval, close interval minus 2 to 9 by 2. So this is the solution of this inequality. Next we move towards B part. B part is very simple. In the second part is inequality is x square minus 1 less than or equal to 3. We will use again the same concept. We can write the given inequality as minus 3 less than or equal to x square minus 1. This is less than or equal to plus 3. Adding 1 on both sides, this gives 1 minus 3 less than or equal to x square. This is less than or equal to 3 plus 1. This is equal to minus 2 less than or equal to x square less than or equal to 4. We have to solve this inequality for real value of x. This shows x square lies between minus 2 to 4. As square of a real number cannot be negative, so we can shrink this inequality as 0 less than or equal to x square less than or equal to 4. Further, we can write it as x square is less than or equal to 4. Taking square root on both sides, this gives square root of x square less than or equal to square root of 4. In our last lecture, we discussed that the absolute value of x is actually equal to square root of x square. So we can replace square root of x square with x absolute. X absolute. What is the square root of 4? This is 2. Now by using this fact, we can write it as minus 2 less than or equal to x, x less than or equal to plus 2. So your solution set is the closed interval minus 2 to plus 2 where x is any real number. So this completes the question number 6. Next we move towards question number 7. Okay, next we discuss question number 7. To solve this question we can use two different ideas. The first idea is very simple. For example, in your school level classes, when you solve x absolute is equal to, suppose this is equal to 5, then the values of x that satisfy these inequalities are plus minus 5. So from here you write x is equal to plus minus 5. So the first idea is very simple. If you open the absolute values of these two absolute values, there are the following possibilities. Either this is equal to plus x plus minus x plus 1 plus minus x minus 2. So now you will write there are the following possibilities. Case number 1. When x plus 1 is equal to positive x plus 1, mean to say its absolute value is positive x plus 1, and similarly the absolute value of x minus 2 is also positive. So in this case, the question number 1 becomes x plus 1 plus x minus 2 is equal to 7. So this gives 2x minus 1, which is equal to 8, x is equal to 4. So this case gives the solution x is equal to 4 here. Case number 2. When x plus 1 equal to negative x plus 1, mean to say its value is negative, and similarly its value is also negative, minus x minus 2. So in this case, the given equation becomes minus x plus 1 minus x plus 1 minus x minus 2 is equal to 7, and this gives minus x minus 1 minus x plus 2 equal to 7. This is equal to minus 2x minus 1 plus 2, this is plus 1, and this is equal to 7 minus 1, and x is equal to 6 over minus 2, that is minus 3. So this is the second solution. The possibility number 3, case number 3. If the absolute value of first is positive and second is negative, that is the absolute value of x plus 1 is positive x plus 1, but the absolute value of x minus 2 is negative, minus x minus 2. So in this case, the given equation becomes x plus 1 minus x plus 2 equal to 7, x cancelled, this is 3 is equal to 7, impossible. So ignore this case. This is not possible that the absolute value of x plus 1 is positive and the absolute value of x minus 2 is negative. This case is not possible. Last case, case number 4. X plus 1 is equal to, absolute value of x plus 1 is equal to minus x plus 1, and the absolute value of x minus 2 is equal to x minus 2. Now the absolute value of x plus 1 is negative and the absolute value of x minus 2 is positive. This case will also not possible. When we put here minus x minus 1 and its value is x plus minus 2, this will cancel x. Again we have minus 3 is equal to 7. This is impossible because minus 3 can never be equal to 7. So there are the following only two possible cases, and for these cases we have the solution set x is equal to minus 3 and 4. So this is the first idea. The second idea is actually related to the definition of absolute value of function that I also discuss here. To understand this idea, you have to focus the definition on you have to focus on the definition of absolute value function. What was the definition of absolute of x? The definition of absolute value of x is simply this is equal to positive x if x is greater than or equal to 0. This is negative x if x is less than 0. Similarly, if you make the definition of x plus 1 absolute, this is equal to positive x plus 1 if the number inside absolute, that is x plus 1, is greater than or equal to 0, or you can write it as x greater than or equal to minus 1. So when your x is greater than or equal to minus 1, then the absolute value will be positive x plus 1. And the absolute value of this number is negative if the number inside the absolute, that is x plus 1, is less than 0, or you can say x is less than minus 1. So when your x is less than minus 1, then its absolute value is negative x plus 1. And when your x is greater than or equal to minus 1, then its absolute value is positive. For example, if you take any number that is less than minus 1, suppose you take x is equal to minus 2. If you put x is equal to minus 2 inside the absolute, this becomes minus 2 plus 1. This is equal to minus 1, that is negative. Similarly, if you take any number that is greater than minus 1, it will give the value positive. For example, if you take x is equal to 0, then this is equal to 0 plus 1. 0 plus 1, this is equal to 1, that is positive. And the absolute value is equal to 0. Actually, you can separate this case in two parts. This is equal to positive x if x is greater than 0. This is equal to 0 if x is equal to 0. So absolute value function can be defined in three parts. This is equal to positive x if x is positive. This is equal to negative f if negative x if x is negative, and this is equal to 0 if x is equal to 0. By the similar manner, you can define the absolute value of x plus 1 in three parts. In more simple words, if I ask if you put x plus 1 equal to 0, then what is the value of x? The value of x is equal to minus 1 here. Similarly, if you put x minus 2 equal to 0, what is the value of x? This is the value of x is equal to 2. So we can say that x plus 1 absolute and x minus 2 absolute change their sign in the neighborhood of x is equal to minus 1 and x is equal to 2 respectively. So these numbers divide the real line into three disjoint regions. This is my real line. This is my first number, x is equal to minus 1. This is my second number, x is equal to 2. The region 1, that is on the left side of x is equal to minus 1. This is my region 1, starting from minus infinity to minus 1. The second one is minus 1 to 2, and the third one is region 3. So we will check these three regions, minus infinity less than x, x less than minus 1, minus 1 less than x, x less than 2, 2 less than x, x less than infinity. We will check which of this interval or region satisfied the given equation. Actually, this is called the real line test, and I will use this method in the following questions, particularly in question number 10. That is very important. So this is the second way to solve question number 7. Clearly, the first method is very easy as compared to this method. Next, we move towards question number 8. Okay, next we discuss question number 8. The one side is absolute value and other side is algebraic number x plus 1. When we expand this absolute value, we have the following two possibilities. Either 2x minus 1 is equal to positive x plus 1, or 2x minus 1 is equal to minus x plus 1. This is similar as when you solve x absolute equal to 5. When you open this gives x is equal to plus minus 5. So there are the two possibilities. Either this absolute value is equal to positive x plus 1, or this is equal to minus x plus 1. From here, this gives 2x minus x is equal to 1 plus 1. This is x is equal to 2. And from here, 2x minus 1 is equal to minus x minus 1. This is equal to 3x. 1 minus 1, x is equal to 0. So the solution of this equation is simple. Two numbers, 0 and 2. B part. Its B part is also very simple. 2x minus 1 is equal to absolute x minus 5. Again, we have a following two possibilities. Either x minus 5 is equal to 2x minus 1, or this is simply equal to x minus 5 is equal to minus 2x minus 1. This can be written as minus 5 plus 1 is equal to 2x minus x. X is equal to minus 4. And this gives x minus 5 is equal to minus 2x plus 1. And this is equal to 3x equal to 6. Yes, x is equal to 2. So the solution set is again two numbers, minus 4 and 2. Minus 4 and 2. This completes question number 8. Question number 9. In question number 9, we have to solve inequality. The inequality is A part. This is equal to x minus 2 absolute less than or equal to x plus 1. And also we have to sketch the graph of this inequality. X minus 2 absolute less than or equal to x plus 1. Yes, this is okay. To solve this inequality, I will use the very good idea, that is the real line test. What is the real line test? This is my inequality. This is not an equation. So firstly, I will find its associated equation. Say this is my inequality number 1. We can use alternative methods also. I have discussed 4 different methods to solve such type of inequality in my previous lectures. You can watch that lectures, and you can use any one of them, any method that you can find best. I will use here the real line test method. This method says this is my given inequality, say this is inequality number 1. Next we find its associated equation. Associated equation of 1 is associated equation of 1 is Reciprocity equation can be framed very simply by just replacing this sign, either it is less than or greater than or less than or equal or greater than equal sign uh, with equal sign, exact equal sign. So this becomes x minus 2 absolute equal to x plus 1. Now this is the same question as we have discussed in question number 8. We have two possibilities here. Either it is equal to x minus 2 equal to x plus 1, or this is equal to x minus 2 minus time x plus 1. From here x will be cancelled and remaining is minus 2 equal to 1. So this is impossible that minus 2 equal to 1. So ignore this case. From here x minus 2 equal to minus x minus 1. This gives 2x is equal to 2 minus 1. X is equal to 1. So there is a one solution for this equation, that is x is equal to 1. Now this number that is x is equal to 1 is called boundary number. This is called boundary number. Boundary number. This boundary number divides the real line into two disjoint parts, like as this is my real line and this is x is equal to 1 minus infinity to positive infinity. Say this is my region 1 that lies between minus infinity to 1, and this is my region 2 that lies between 1 to infinity, and 1 is the boundary between these two regions. We will take any test point from both of the regions and we'll check does this point satisfy the given inequality or not. So firstly we test region 1. For region 1, in region 1 our x lies between minus infinity to 1. I can take x is equal to 0 from this region. Put x is equal to 0 in 1. Put in 1. What is 1? This is 1 is my original inequality. So put x is equal to 0 here. This gives 0 minus 2 less than or equal to 0 plus 1. 0 minus 2 means minus 2 absolute. This is equal to 1. Minus 2 absolute is 2. 2 less than or equal to 1. Is this true? No, this is false. This is false. This shows that there is no solution in the region 1 for the given inequality. Similarly, now we test region 2. Region 2 start from 1 to infinity. 1 less than x, x less than infinity. Take any number from this region. Suppose you take x is equal to 2. Take x is equal to 2. If you put x is equal to 2 in the given inequality, this becomes 2 minus 2 less than or equal to 2 plus 1. This is equal to 0. 0 less than or equal to 3. This is true. This shows that the solution lies in region 2. So, solution set of the given inequality is x belong to our interval start from 1 to infinity. 1 to infinity. You know, from infinity side, we cannot close the bracket. So this is open now. Either it will be open or it will be closed. This depend on the sign of inequality number 1. In inequality number 1, you can see there is an equal sign here, x less than or equal. If the equal sign is present in the inequality, we will take close the interval from to the side of from side of 1. If this sign is less than only, then this will be an open interval. So this is the fact. Next, we have to sketch the graph of this inequality, and we have to interpret the graph. Okay. You know the graph of standard absolute value function, that is y is equal to x absolute. Y is equal to x absolute. The graph of this standard absolute value function is a V shape passing through the region. So to make, firstly we make the graph of this number x minus 2 absolute. Y is equal to x minus 2 absolute. This will be also a V shape, but there will be some change. What is x-intercept? The x-intercept of this graph is simply, if you put y is equal to 0, this is equal to x minus 2 absolute, this gives x is equal to 2. This is x-intercept. And what is y-intercept? The y-intercept, if you put x is equal to 0, then your y is equal to 2. So this is your y-intercept. So the graph of y is equal to x minus 2, it will touch the x-axis at x is equal to 2 and y-axis at y is equal to 2 here. So suppose this is the graph. Suppose this is x is equal to 2, y is equal to 0, and this is x is equal to 0, y is equal to 2. This is y is equal to x minus 2. Next we make the graph of y is equal to x plus 1. Very simple, y is equal to x plus 1. When you put x is equal to 0, your y is equal to 1. This is y-intercept. When you put y is equal to 0, your x is equal to minus 1. So x-intercept is minus 1, y-intercept is 1. The graph of this line is suppose this is my x is equal to minus 1 and this is y is equal to 1. So this is the graph of y is equal to x plus 1. This is the point of intersection, and this point is actually when you put x in this boundary number x is equal to 1 here, sorry, I have done some mistake here. From where x is equal to 1 by 2. So your solution will be lies here, x is equal to 1 by 2 to positive infinity. Yes, your number line will be divided by x is equal to 1 by 2. So there are the two regions, minus infinity to 1 by 2 and other is 1 by 2 to positive infinity. Sorry. So the point of intersection is x is equal to 1 by 2, and what is y? Y is here 3 by 2. So this is 1 by 2 and 3 by 2. This is the point of intersection. Okay. Now your graph between these two inequalities lies here in this interval. From the graph you can see that geometrically this inequality shows the graph of y is equal to x minus 2, graph of y is equal to x minus 2 lies underneath the graph of y is equal to x plus 1. From graph you can observe that the graph of y is equal to x minus 2 lies below the graph of y is equal to x plus 1 for the interval x is equal to 1 by 2 to positive infinity with their common value, that is point of intersection 1 by 2 comma 3 by 2. And this completes question number 9a. Okay, this is question number 9b. 3 absolute x less than or equal to 2 minus x. I hope you can do this question by yourself. This is very easy. Still, if you find any hurdle in this question, you can message me, inshallah. I will solve this question. Next, we will discuss question number 10a. We have the given inequality x minus 1 absolute greater than x plus 1. We have to just find the solution of this inequality without sketching the graph. Can we write it as by dividing x minus 1 absolute on both sides? This gives 1 greater than x plus 1 absolute over x minus 1 absolute, provided that x is not equal to 1, because if x is equal to 1, then this inequality becomes undefined and division is not possible. Further, you can write it as 1 greater than x plus 1 over x minus 1 absolute, or you can write it as x plus 1 over x minus 1 absolute less than 1. So say this is my inequality number 1. Again, there are several methods to solve this inequality. I will use the real line test. I will make its associated equation. The associated equation is x plus 1 over x minus 1 is equal to 1. This gives us x plus 1 over x minus 1 equal to plus minus 1. So either x plus 1 over x minus 1 equal to plus 1, or this is x plus 1 over x minus 1 equal to minus 1. This gives x plus 1 equal to x minus 1. From here, after subtracting x from both sides, this becomes 1 is equal to minus 1. This is impossible. So ignore this case. This becomes x plus 1 equal to minus x plus 1. This is equal to 2x is equal to 0. 2x is equal to 0. Yes, x is equal to 0. So this side gives a solution x is equal to 0. This x is equal to 0 is called actually boundary number. While this number x is equal to 1 is called free boundary number. A number for which the given inequality is undefined is called free boundary number. So x is equal to 1 is a free boundary number. This is free boundary number. While that number is called boundary number. So we mark these 2 points, boundary and free boundary number, both on the real line. These 2 points divide the real line into 3 disjoint parts. This is x is equal to 0, this is x is equal to 1, This is my minus infinity, this is plus infinity, this is my region 1, region 2, region 3. Now we will take any test point from each of the region. You can write all of these steps properly. If you take any point from this region, suppose if you take x is equal to minus 1. If you put x is equal to minus 1 in the given inequality here or here, we put here x is equal to minus 1, suppose. This becomes minus 1 greater than minus 1 plus 1. This is equal to minus 2. Absolute greater than equal to 0. That is 2 greater than 0. So this region satisfied the given inequality. So one of the solution lies in this interval minus infinity to 0. If you take any point from here, that is 0 to 1. 0 to 1, if you take x is equal to 1 by 2. X is equal to 1 by 2. 0.5. 0.5 lies in region 2. If you put 1 by 2 in the given inequality, this becomes 1 by 2 minus 1 greater than 1 by 2 plus 1. This is 1 by 2 minus 1, this is 1 by 2. Minus 1 by 2, absolute value of minus 1 by 2 is 1 by 2. 1 by 2 is greater than 3 by 2. This is not possible, not true. This is false. So there is no solution in region number 2. Now we take any other point in region 3. Suppose you take x is equal to 2 from this region. If you put x is equal to 2 in the given inequality, this becomes 2 minus 1 greater than 2 plus 1. 1 greater than 3. This is also false. So there is no solution in region 2 and region 3. So there is only one solution in region 1. So the solution of the given inequality is minus infinity less than x, x less than 0. As the given inequality has a no equal sign, so this will be open interval. So you can write x belong to minus infinity to 0. So this is the answer. Okay, next we discuss the last part of the today's lecture, question number 10b. Question number 10b. Question number 10b is x absolute plus x plus 1 absolute is less than 2. Yes. This question is actually have the same concept of question number 7. But in that question number 7 was an equation. Here this is an inequality. Firstly, we make its associated equation. What is its associated equation? X absolute plus x plus 1 equal to 2. Now I will solve this question by first method of question number 7, that was case number 1. There are the following possibilities for these two absolute values. Both are positive, both are negative. One of them is positive, another is negative. If both are positive, then x absolute is equal to x, and x plus 1 absolute is also equal to x plus 1. This gives us x plus 1 equal to 2. This is equal to 2x plus 1, which is equal to 2 minus 1, and x is equal to 1 over 2. So this is the boundary point, boundary number for this equation. Say this is my inequality number 1, this is my equation number 2. Actually, when we solve an equation, then the boundary numbers are called actually the solution of the given equation. But in case when we solve an inequality, the boundary numbers are not only the solution of the given inequality. In case of inequality, the solution set is always in the form of intervals. So this is the first boundary number for question number 2. Case number 2. Next we discuss case number 2. In case number 2, we suppose both of them are negative, have a negative value, absolute value. Absolute value of x is minus x, and absolute value of x plus 1 is equal to minus x plus 1. So in this case, the given question number 2 becomes minus x minus 1 equal to 2. This is equal to minus 2x is equal to 3, implies x is equal to minus 3 by 2. This is the second boundary number. Okay. Clearly, case number 3 and case number 4 are not valid. Otherwise, you can check here. Case number 3. When one of them is positive and other is negative. When x absolute is positive and x plus 1 is negative. Because in this case, in these two cases, the following two cases, x will be cancelled. So when we put x absolute is equal to x here, this becomes x minus 1 equal to 2. This is equal to minus 1 equal to 2. This is not possible. So left this case. Case number 4. When x absolute is negative x and x plus 1 absolute is positive x plus 1. So in this case, the question number 2 also becomes minus x plus 1 equal to 2. 1 equal to 2. This is not possible. Impossible. So ignore this case. So now we have only two solutions. There are the only two boundary numbers. One is minus 3 by 2 and another is 1 by 2. So we will write these two boundary numbers, divide the given line, a real line, into three disjoint parts. And these three disjoint regions are, this is my x is equal to minus 3 by 2. This is x is equal to 1 by 2. This is minus infinity. This is positive infinity. This is my region 1. This is my region 2. This is my region 3. We will take a test point from each region and check which of the regions satisfies the given inequality. Okay. For region 1, region 1 is minus infinity less than x, x less than minus 3 by 2. Take x is equal to minus 2. Minus 2 lies in this interval, in this region. Put x is equal to minus 2 in the given inequality. This becomes minus 2 absolute plus minus 2 plus 1. This is equal to 2 and this is equal to 1. That is 3. 3 is less than 2. No, this is false. So region 1 does not satisfy the given inequality. Take any point from this region. Is 0 in this interval? Yes. Minus 3 by 2 less than x, x less than 1 by 2. Take x is equal to 0 from this interval. When we put x is equal to 0 in the given inequality, this becomes 0 absolute plus 0 plus 1. This is equal to 1. 1 is less than 2. Yes, this is true. This shows that region 2 satisfied the given inequality. Lastly, when your x is greater than 1 by 2, region 3, x is greater than 1 by 2. Take any point from this interval, take x is equal to 1. Put x is equal to 1 in the given inequality, this becomes 1 absolute, 1 plus 1, 1 plus 1, 2, 2 plus 1, 3, 3 less than 2. No, this is not possible. So region 3 also does not satisfy the given inequality. So there is only one region that satisfies the given inequality, that is region 2, and region 2 start from minus 3 by 2 to 1 by 2. So the solution of the inequality 1 is open interval x belong to minus 3 by 2 to 1 by 2, where x is any real number. Why this is open? Because the given inequality has a no equal sign. Otherwise, we will close the interval. So I hope now you have a clear understanding of today lecture. If you find this lecture helpful, kindly like, share and subscribe. If you find any hurdle, any problem in this question, you can comments me. Inshallah, I will reply you. So in the next lecture, we will discuss question number 11. That is very interesting. So see you again in the next lecture. Take care. Allah Hafiz.